Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. We are going to learn object-oriented paradigm, association. This is another kind of relationship between classes. In the previous lectures, we have learned inheritance, aggregation, and composition. Surely, in an object-oriented software system, classes will have some kind of relationships between each other. Some are inheritance, and some are aggregation or composition. If two classes have relationship between each other, but it is not inheritance and not aggregation or composition, and it must be association. So let's look at the examples. In a software system, let's say student is a class and the course is a class. Surely the relationship between student and the course is not inheritance. It's not aggregation and it's not composition. But we cannot deny that there is some kind of relationship between student and the course. So what is it? Well, in the system, the student may take course. So we call it takes. We use the word takes to describe the relationship between student and the course. Okay? So such kind of relationship is called association. Well, let's look at another example. Let's say in an e-commerce system. Now, I believe all of you have bought something from the website, from some e-shops. And there are quite some famous e-shop systems in China, right? Such as Taobao and so on. Okay, so when you try to buy something from the e-shop, you are the customer. And if you want to buy something, you must place order. So that means surely there are some relationship between customer and order. It should be described in this way. Customer places order. So the relationship between customer and order is association. Let's go on. Still this example, customer places order. Well, we should never forget the multiplicity between these two classes. Actually, we should describe the relationship between customer and the order in this way. One customer, that means each customer, can place no order. It is allowed, okay? It's okay if the customer hasn't placed any order. But of course, the customer can place orders, maybe one or two or many. There's no limitation, surely. So the multiplicity for order should be 0 and more. So here, customer is indicated as 1, and the order is indicated as 0 and more. Well, let's go back to the example of aggregation or composition. Let's say in a game, there's a human being. I'm sure that many boys love e-games. And usually there are some fighters or some soldiers in the game, right? Okay, so we can just call it game human being. Surely this human being in the game is composed of head, body, arm, and leg. And one human being, one game human being has one head, one body, 2 arms, and 2 legs. We can see that for the relationship of aggregation or composition and association, we should never forget multiplicity. So that means each class engaged in a relationship should have a multiplicity, except inheritance. So multiplicity is only for aggregation, composition, and association. Well, we should never forget 1. If the multiplicity is 1, it indicates that it is 1. In order that reader know that multiplicity has been considered. So you can't just ignore 1. In the previous examples, we just give some examples of multiplicity, but surely there are more multiplicity indicators. So let's look at this list of UML multiplicity indicators. See this 0, ... 1. That means 0 or 1. That means only 1. 0 ... star means 0 or multiple. And 1 ... star, that means 1 or multiple. And n means some exact number. Okay, maybe it's 4 or 2 or 10 or 30 and so on. So that means it's just some exact number. It's up to the business requirements. 0 to n. N is bigger than 1. Otherwise, you can just use 1 if n is 1. And 1 to n. And n to m. Okay, that means from n to m. And both n and m are some exact number. Okay, and both n and m should be bigger than 1. And n or multiple. Okay, so that means n or more. So when we try to achieve class diagram for aggregation, composition, and association, we should never forget multiplicity, such as these two diagrams. Okay, so much for this point. Thank you.